Okay, I think we're live. Good evening, everybody. My name is Mike Jerry, and welcome to the Death Valley region of California, where tonight we got some beautiful skies. It's been a beautiful, calm evening up until the last 5 minutes, when all of a sudden a whole bunch of wind has come up. So, obviously you can hear it in my mic, I'm sure, but yeah, well, we'll see how this goes. Hopefully this is just a brief little dust up, and we won't be at it for long here, but hopefully we'll see. Well, we'll see what happens. But right now we've got a bit of a breeze showing up. So let me turn the test pattern off, and let me put this screen down to something you guys can see here. So here's our June EAA Observing Challenge from Cloudy Nights by M. Frado. Thanks for putting this up. Looks like a nice little list. The first thing we're going to want to do, though, is 2537, because this one is fairly low in the northwestern sky, and it'll be a little bit of a question of how well I'll be able to get it. So yeah, we've got a pretty darn nice looking night, except hopefully for this wind that will hopefully die down here. But in the meantime, let's go to this first object and see if we can get to it. NGC 2537, the bear paw. NGC 2537, the bear paw. Ooh, that's very, very low. Am I going to be able to get there? There's those two there. Ha! I don't think I can even get there. No, I can only see. I can't quite see this star. I've got a roof line that's like right in here, so I don't think I can even get to that galaxy. Let's say, can I see that other star? I can't see that other star. Oh, let's slew over there and see what happens. Let's see where the scope ends up pointing. Who knows? I might be able to catch the last couple of minutes of it here. No, that's solidly right into my house. So that is definitely not going to work. I'm just realizing you guys can't see my old screen here, so I've got to resize this so that you can. Okay, something like that. Yeah, so that object is really a winter and spring object, and so not going to be able to see that one. So we'll have to just skip that one. So let's just start at the top. So NGC 6543. NGC 6543. Alright, so this one is up near Ursa Minor, the Little Dipper, right there. So this one should be more in our wheelhouse. So let's give this one a try. Swing back over here. And this one should be a lot easier. Okay, let's go over to SharpCap and plate solve in on that baby. And then let's see. Oh, that may be it. That bright object right there may actually be it. Okay. Alright, let's turn our enhancements on here. I can't get down to the bottom. Whoa! Wow, what just happened there? Okay, that went a little crazy. This is what I've got to get at right there. Couldn't see it without... Okay, let's restart this. Let's restart this. Level everything off. Get that all out of the way. See what our first 60-second sub look like. Yeah, hopefully we will, this breeze will calm down. Hopefully that was just a little bit of a 15-minute dust up here. Okay. Okay, bring this up here. Yeah, I think that's just a little planetary nebula in there. Oh boy, yeah, there is a little something in here, isn't there? Cat's Eye Nebula. Yeah, it's a planetary, so it's a very small little guy. Looks like there's a little nebulosity out here, too. Alright, cool. Well, let's see what a few more sub-exposures will bring in. Okay, in the meantime, 6543. Let's see what Wikipedia has to say about it. NGC 6543. Cat's Eye Nebula, discovered by William Herschel in 1786, was the first planetary nebula whose spectrum was investigated by the English amateur astronomer William Huggins, demonstrating the planetary nebula were gaseous and not stellar in nature. Cool. Structurally, the object has had high-resolution images by the Hubble Space Telescope, revealing knots, jets, bubbles, and complex arcs, being illuminated by the central hot planetary nebula nucleus. It's a well-studied object that has been observed from radio to X-ray wavelengths. High surface brightness. Let's see if it tells. Whoa! Let's see if it otherwise. Oh, how far away is it? I still can't find where it says how far away it is. The colors, the temperatures, information about the central star, but it doesn't say exactly, it doesn't say where the heck it is. Huh. Radius, magnitude. Interesting. Well, this whole long entry in Wikipedia that talks about it does not say how far away it is, which is just odd. Talks about all the different forms of planetary. Okay, distances are generally very inaccurate, not well known. Oh. About 3,300. Well, they're guessing about 3,300 light years, but they actually don't really know for sure. Unfortunately, with my scope, we're not going to be able to really see much of any detail. It's so small that it would take a telescope of significantly higher focal length to be able to really see any of the detail in it. Maybe one thing I could try to do is back the stretch off a little bit, dim it down to see if we can actually see any of the interior structure. It's just basically a really, really small little donut. And sort of an oblong donut, but a donut nonetheless. I don't know. Well, another thing I could try is reducing my exposure. So let's try reducing the exposure to 30 seconds and see if that'll help us pick it up a little better. Might even have to drop it again to 15 seconds. Again, sorry about the wind noise you guys are hearing a lot of here, but trust me, until 5 minutes before I hit the broadcast button, this breeze was not here. So it just saved it all up just for my broadcast. Let's see what this sub looks like. Let's see if we can back this off and you can see any of the we start to see some of the bluish color at least. Planetary nebulas have two real significant characteristics. Number one, they're really small for the most part, although there are a few exceptions, and they're really bright. See here, I think we can actually start to see a little bit of the inner structure, just a little bit. So I'm going to pick this and go down to 15 seconds. See if we can see any of that detail in there. Let's see what we can do with this. Yeah, see that's a little. Now we're kind of seeing the central star a bit. Let's let a few subs stack on this and see if. Now you're seeing obviously we're zoomed in so far. We're seeing the pixel. I'm zoomed in 450%. So we're actually seeing the individual pixels of the camera at this point, which is obviously not ideal, but planetary nebulas are really small objects, and they're better suited to refractors and much longer focal length scopes than what I'm using. In fact, I should show you what I'm using. Hold on, I'm going to take a drink here. Okay, speaking of what I'm using, let's take a look. So this is my telescope setup. A 6-inch imaging Newtonian telescope with a camera stuck in the focuser up here, an AM5 mount that drives it around the sky and tracks the sky so we can take our images, and my spare no expense cinder block pier, and I'm sitting here behind this laptop talking to you while we do this. So this is what I'm using for my setup, and this kind of setup it's a relatively short, small telescope, so it doesn't have a lot of focal length. So it's not very good for small, sharp objects. It's really good for larger, more diffuse, faint objects. It's really good for it's a good light collector for faint, larger objects, and it does a great job with those. But really small stuff, not so much. But you can see, even though we're looking at individual pixels in the camera at this point, you can definitely see the central star here and the cloud that is surrounding it. A planetary nebula is basically the death process of a star not unlike our own, that in 5 billion years or so is going to run out of fuel, and it's going to begin swelling up and blowing outer layers off. In fact, it will grow, it'll turn into a red giant, our sun will, that will be so big that its size, the star, will actually swallow up possibly even as big as the entire orbit of the Earth. It will just really grow up massive. And then the outer layers will just keep blowing off and spreading out. And what it will leave is a core. At the very core, the core of the sun will stay, and it will continue burning. It will just be much dimmer and cooler, but it actually ignites, ionizes, and radiates the gases that are blowing out as it blows out and expands. And so that's what a planetary nebula is the core star that's left. All this used to be the star, and the outer layers have blown out and gotten really big, and the inner part is still there, burning, just much more dimly, but it's enough to illuminate, ionize all the gases that are blowing out away from it. And that's what a planetary nebula is. A dying star, essentially. Let's see what else we got here. Yeah, another planetary nebula here, and then a cluster. So then a tiny object like this, I don't know that I'm going to be able to pull a whole lot more detail out of it. But you can see enough to know that it's definitely not a star. It's definitely an actual object. And it's an interesting object, especially if you've got a more let me turn the background music on here. Especially if you've got a larger telescope, a longer focal length telescope, I should say, which will give you a lot more magnification. It'll make the object a lot bigger looking and get you more detail. But I think what we'll do now is let's see where's the next one. Planetary 6572. NGC 6572. Oh, wow. All the way around the other side of the sky. Let's see, are we going to be able to see that? Yes. It's above. Okay, yes. Okay, we're good. Yeah, we should be able to pick that up. That should be high enough. Okay, so, and then when you look at it normal size, that's how big it is. The thing is tiny. It's almost indistinguishable from a star. They're so small. Okay, let's go to the next little planetary nebula, which is all the way down in the southern end of the sky here. Alright. And we'll plate solve to center that up. Yeah, and that's probably it right there. Okay. We'll do this. And then I will just automatically reduce the exposure to 15 seconds as soon as this is done. I will just automatically reduce it. Okay, you can shrink back down now. Alright, let's see what we got here. Yeah, so you can see it's just a little bit bigger and fuzzier than a star. So these here are stars. It's also less bluish in color as well. Again, we have to zoom way, way, way in. This one does look a bit bigger. much out of this one. Let's back it way off. Got a little bit of structure out of that last one. Wonder if we'll get any out of this one. Maybe not. We might not see much of anything out of this one. Well, if so, we'll just move along. It's the Blue Racquetball Nebula. You definitely see the color in it when I had it more stretched. What the heck just happened there? Okay, somehow this has gotten all screwed up here. Pull the stretch back in, you can see that it's definitely a bluish in color. It's not the more yellowish stars around it. These are more whitish yellowish stars. This has definitely got a blue hue to it. So you can tell, and it's blobby, so you can tell it's not just a star like all the other things around it. You can tell it's definitely something different. But I'm not getting any much detail out of it. I don't know, maybe if you do a little bit of averted imagination, you can see that there's a bit of a darker spot in there, maybe, but I don't think we're seeing a whole lot out of that. And I don't think we're going to with my particular telescope. I don't think there's going to be enough there to really be able to see much of anything. Yeah, in fact, I think we're just going to move on from that. I'm not going to be able to see much of anything from that. It's too small. Just too small. So, let's go to something much bigger, which is a cluster. 7160 NGC 7160 Swimming alligator cluster. Okay, so back up kind of the way we came. Swimming alligator cluster. I think this might be it up here. Bring it right down into here. Yep. So I think this is it right here. Swimming alligator cluster. Started moshing. And like planetary nebulas with clusters, globular clusters, open clusters, etc., stars are very bright objects. We really don't need, we're around 15 seconds again, really don't need very much, boy, this thing's expanded way huge again. Really don't need to have very long exposures to capture star clusters. The stars are bright, bright objects. Doesn't take much exposure time. Okay. Yeah, there's our little swimming alligator cluster and its surrounding field of stars. Some pretty little stars in there. Another really small object. This person must have some long focal length stuff, because it's not a lot of light bucket type objects. out of really small bright objects. So he may be a refractor person. Refractors are much better for smaller, brighter objects, which is not what I have, but I can still get some decent images out of it. Planetary nebulas, though, those are a little bit small, except for the biggest ones. Those are a little bit small for me to be able to see. Okay. See how our guiding is doing here. Guiding is terrible. Oh well. What are you gonna do? In this wind, you can only do so much. Back into control a little bit here. That's better. Alright, so where are we here? 7160. What? NGC 7160. It's right there. It says there isn't a page, but there's a page. Okay. This also was discovered by William Herschel in 1789. It's a poor cluster and with little central concentration. It's part of the stellar constellation Cepheus OB2. It's a young cluster whose age is estimated to be between 10 and 19 million years. The cluster presents no extended infrared emission when observed by the Spitzer Space Telescope or the Herschel, which suggests that the molecular cloud in which it was formed has been removed. Radius of the cluster 16 stars. Probable members of the cluster are located within the central part of the cluster, and 71 probable members are located within the angular radius of the cluster. About 400 light years away. Wait a minute. No, that's a different... No. Again, no indication of where the distance is. I don't see anything in here that indicates the distance. So, don't know how far away it is. But it's a pretty little cluster. It is a pretty little cluster. So about 16 of these stars are central to it, and I think there's 70 or so around it that are sort of members too. Okay. What's the next object? So we've done all of these. Now we get to galaxies, and this is what my scope is much better designed for. Then he's got a bunch of comets here. Well, he's got another planetary. I don't really do comets, which I'm not, so we're going to skip the comets, but 5529 we can do. NGC 5529. Okay, back over the western sky. Alright. It's not a very big one, but it'll do. But that's a pretty little cluster. I don't know why how they got a swimming alligator out of it. Back off. Somehow it's a curvy tail, and I don't know. Not sure how you get a swimming alligator out of that, but let's go do our first galaxy. So that means we're going to have to flip around to the other side of the meridian here. Okay. Center on it. Wow, 3.5 degrees. Okay, well, let's see what we can see. Feels like the wind maybe is calming down a little bit. That's a good thing. Okay, NGC 5529. It's an edge-on intermediate spiral galaxy that's located approximately 144 million light years away. Discovered by, da-da-da, guess who? William Herschel in 1785. It's located near dwarf galaxies PGC 5592 and PGC 50925. Well, we'll see if we can't. Okay. This is not looking like we're seeing anything in there. There's nothing in there. Okay, so it looks to me like the plate solve lied to us and did not put us on the target somehow. Okay, let's see if it's here. I don't know why this thing keeps expanding to huge size like this. I set it... Oh, come on. I set it down and it goes back up, and I set it down and it goes back up, and I set it down and it goes back up. Well, let's see if we have better luck with this one. yeah, I'm not sure why it lied to me the first time. It was right on. Okay, let's color balance that. And get us a little bit better balanced. And now you can see some nice bright stars around here. There's a nice little trio of stars there. Oh yeah, you can see there's definitely some fuzzy things here. Yeah, that's a fuzzy one right there. Well, we'll wait till we get a few sub-exposures in, and then we'll zoom in a little more and stretch it a little more. See, these are the kind of objects that my scope excels at. The fainter, larger things, but really the faint objects are what my scope does well. Come on. 144 million light years. So you can see there's actually a dust lane cutting right through it here. Which, as we get some more subs in, will become more and more apparent. And so will these dwarf galaxies. Here we got one there, got one there, got one here. This is definitely looking like one down here. Bunch of little galaxies in here. And there's a nice satellite strike making an appearance right through there. I'm going to try and keep myself muted a bit more than normal because of all this annoying wind noise. Again, I apologize for it, but it was a beautiful, calm evening until 5 minutes before I hit the broadcast button. And then this wind just came up, and so annoying, but what are you going to do? Answer: I'm going to keep myself muted more. I don't know how well you can see this, but there's definitely a dust lane cutting right through an edge of it, right there, the edge of it, cutting right through, showing us that edge-on galaxy. This is looking like a very interesting shaped galaxy up here. These are just kind of blobby and whatnot. But this one actually looks like it's got some structure and some shape. Kind of like a dot within a circle. See what the annotation. UGC 9123. Interesting. Yeah, look at this whole string of galaxies in here. Oh, a bunch of little galaxies in there. But this one's very interesting. Mag 16. But obviously some structure in there. Pretty neat. Alright, the next object is going to be NGC 2537. Oh no, that's right. We already said we can't do that one. That one's way too low. And M64. Whoops, wrong window. This one, then this, then this, then this. Yeah, M64. That's a nice galaxy. But this way definitely got a nice dust lane through here. And a nice little array of galaxies. A string of galaxies here. A string of galaxies here. String of galaxies here. With this really cool looking one. This one's actually pretty darn neat. That's pretty darn neat there. Could even risk stretching this a little bit more to see if we can't we'll get a bit grainy, but definitely see some structure in there. That's a pretty cool looking galaxy there. And definitely one here, here. Neat. Okay. Let's go to M64. Alright. Yeah, this is it right here, I'm pretty sure. Bring that right up there. Yep. Alright, M64. Okay, so this is M64, or the Black Eye Galaxy. You can probably see why it's called the Black Eye Galaxy. It's got this dark section in here. It's a pretty nice looking galaxy once we get a few more subs going on it with a nice central region and then some wispy outer parts. It's about 17 million light years away from us. So in galactic terms, that's pretty darn close. It's one of our more local neighbors. But the 64th object in Charles Messier's catalog. And by the way, what creates that dark band right there that gives it its black eye is it's just a dark layer of light-absorbing, light-blocking dust that's just between, basically on the top of this, so it blocks the light from getting through. Gives it that black eye sort of appearance. So it's just dust, kind of like the dust lane we saw in the last galaxy, which was around the edge, which is how we knew we were, you could see it on the very edge as we were looking edge on. Well, this one's got a dark dust spot that's in here, and so it blocks some of the light that from the stars that are underneath here. But it's just basically light blocking, light absorbing dust that causes this. I think we're going to take a little detour from the challenge. I'm pretty much at the comets I aren't really going to do. Planetary nebulas are too small, so I'm not going to really do that one. So other than the galactic center, which we'll work our way toward a bit later, I think I'm going to, I think we're kind of done with the stuff that I can really do well. So since we're over here in the galaxies, I think we're just going to do a few galaxies next. So I think we'll probably do the Needle galaxy next. But we'll give this a few more minutes, and then we'll move on to the next. In the meantime, I'm going to keep myself muted a bit more than normal because otherwise you guys are just going to get a bunch of wind noise in my microphone when it does gust up. It seems like it's trying to calm down a little, but there's still some pretty good gusts of it. So I'm just going to keep myself muted a bit. You can see as I get more subs in, starting to get more structure in here. Some a nice gap in here with some of the arms that are swirling around. Starting to see a little bit more structure to this, a little bit more dust lanes in through here as we get more sub exposures. Cool. Well, there was 16 minutes on M64, the Black Eye Galaxy. Got a little bit of detail out of that one. Pretty neat one there. Okay. Now we're going to go to the Needle Galaxy. Oh, yes, but my computer does not like it when you don't turn the guiding off first. Okay, we shouldn't need a plate solve this, it was just a short hop. So let's go see what the Needle Galaxy looks like tonight. Yeah, there's that Needle Galaxy. Again, another perfect edge on. This one's bigger and clearer, where you can really much more clearly see the dust lane. It's much darker and sharper because this is bigger. You know, we see it a lot bigger than the one we saw a couple galaxies ago. This is a pretty one. Obviously with a companion up here, and a few more out here. If I hit my annotation. These are definitely galaxies in here. Not sure why it's not indicating them in my catalog, but there they are. Definitely a few galaxies around. So the Needle Galaxy is 30 to 50 million light years away. That's a pretty big range. Somewhere in the 40, give or take, million light year range, I guess. Discovered in 1785 by guess who? William Herschel. Prominent example of an edge-on spiral. It's a giant spiral galaxy more luminous than the Andromeda galaxy. Its exponential shape suggests it's a barred spiral. Has two satellite galaxies, one of which is interacting with it. There's a population of roughly 240 globular clusters, more than the Milky Way. It's one of the brightest members of the Coma 1 group of galaxies. The Hadron Galaxy exhibits a slightly warped and extended disk under deep optical surveys, likely due to ongoing interactions with neighboring satellite galaxies or other galaxies in the Coma 1 group. Galex images show the slight warp at the edge of the disk more clearly than other surveys. Looks pretty straight to me. Okay, Needle Galaxy, that's pretty good. Let's change this. No, not you, no, not you, yes, you. Yeah, that'll work. Got a bit of a group of galaxies here. We'll go to that next. This is a nice one. So the next one we'll do is sort of a smattering of galaxies. But we're getting a little low in the sky, but I think I can get them. Okay. This is going to be M84, M86, and friends. Yeah, you can see how this is all light here. It's because this is all dropping into a roof line, and the light is starting to get cut off, reflecting off the side. So, yeah, we'll just do a couple of subs here. Yeah, we need to pick something higher in the sky than this. We need to pick something higher in the sky than this, because it's, that'll work. We'll take a couple of subs on this, but then we'll go to these. We got 3 other Messier objects in there. Yeah, that's pretty lousy there. It's right on the edge of a roof line. Galaxy season is coming to a close, and so they're getting kind of low in the sky. This is just going to keep getting worse. So, nope, life's too short to get nasty things, so we'll get better image of a few more. So this will now be M58, M90, and 89. There we go, that's better. That's a lot better. Some neat spirals in M58 and 90. But you can see even this one is picking up a little bit of the roof line. That's okay. This will be the last go we have of this, and I think we're going to head over and do the last object in our challenge. Get this microphone a little way. And over the galactic center, maybe do a couple of objects over there, which are going to be big, bright, pretty objects. So stay tuned for that. think that bright spot is growing too big, so we're going to take this one last sub and then head over to the new objects. And I'm just realizing I forgot to change the date on the title of this live stream. I just basically reused the old live stream to create the new one. I forgot to change the title, the date and the title. Duh. Okay, well that sub failed, so we're just gonna head over and do. Okay, so. Alright, so now we're going to head over and do the... No, wrong way. We're going to head right around here and look at Sagittarius. And the galactic center is somewhere like over in here, which is close enough. This whole region is pretty densely populated with stars, but okay, so we're done there. So now we're gonna have to slew all the way around. Okay, plate solve to get us in the neighborhood here. 0.19 degrees, wow, impressive. Okay. It's a very impressive area of stars, because we're looking, basically it's the center of our galaxy here. So very rich, dense star fields in here, among many, many other things. It looks to me like the mountain was moving a little bit. In fact, I'm going to reduce exposure on this to 30 seconds. Start this over. Just very dense star fields here, because we're looking toward the center of our galaxy, so just lots and lots of stars and thick clouds, which is what the southern Milky Way is right now. If you go out and look up in the southern sky, you'll see the southern Milky Way up there. Looks like wisps of clouds up above us, but those are actually stars. And this is what it looks like kind of close up. You can even see a little bit of red nebulosity showing up here up at the top. A little bit. So there's gases in these areas too, not just stars. If I can change that title. I don't know if I can change the title before I actually finish the... Oh, that's not useful. Whoops. Edit title and description. I can. 6/29/24. There we go. That's better. Just a really dense star field. You can just get as deep into the weeds here as you want. Just go cloud hopping. Like shooting clusters. Come on, go away. Only short exposures are required for this because it's all stars. Just really bright stars. Just really thick. You can see where this is almost normal space here. And just the really thick clouds of stars, basically. This is all just stars, as we see. Part of the reason we don't really see a big bright core to our galaxy is because, like the black eye galaxy, where we saw that black eye being caused by dust blocking and dust absorbing, light blocking and light absorbing dust, there's a lot of that same kind of dust between us and the core of the Milky Way. So when you go outside on a warm summer night and look to the south and you see the Milky Way above you, you're looking toward the center of our galaxy, but you can't really see a whole lot. I mean, you can see the wispy inner arms up there, but you can't really see the core of our galaxy, which is pretty bright, because it's just blocked by a lot of dust, light absorbing and light blocking dust. But there's a few places where it pokes through, where we actually see through the clouds, and this is kind of what it looks like looking toward the center of our galaxy. Just bright clouds of stars, where they get pretty dense toward the center of our galaxy, but they look like they're banging up against each other, but the reality is there's still light years between all the stars, even the ones that look like they're really, really densely packed. Everything in a galaxy is just so big and so far away. And even the bright cores of the galaxies, there's still light years between stars. So, but they're really pretty to look at from a distance. So when you look up at the southern sky and see the Milky Way up there, this is what it looks like through a telescope. Just really thick clouds of bright stars. Pretty spectacular. We'll go to the Lagoon Nebula next. My first time imaging that this year. Okay. The Lagoon Nebula. This will be a pretty bright, shiny object. Hi, John. Yes, just UVIR cut filter is all that I'm using on my 183 color camera. So the Lagoon Nebula is a star-forming region, so this is definitely a stellar nursery where stars are being born. It's about 5,000 light years away from us, right toward the center of our galaxy. These dark patches here are called Bok globules, areas of dark collapsing matter that are creating new stars as well. They're protostar forming regions. So definitely a neat object. Certainly pretty to look at. These dark pockets called Bok globules. Place where all new stars are made. Our sun was formed in something like this about 5 billion years ago. Let's go to another pretty thing. The Trifid Nebula. Gotta watch that meridian. Don't want to bang into that if I can help it. The Trifid Nebula is neat because it's all three kinds of nebula in one object. There are three kinds of nebulosity: reflection, emission, and dark nebula. And this is one of the few nebula structures that has all three in one. So, kind of a neat thing. And there it is, the Trifid Nebula. The red part is what's called an emission nebula, where the stars inside it are actually irradiating the gases and causing them to emit their own light, in this case in the form of hydrogen, which makes it red. The blue side is reflection. Gas is actually reflecting starlight from interior and surrounding stars, so it's blue. And then all of these little pathways through here, the veins, if you will, through the nebulas are regions of dark nebulosity. Kind of like with the galaxies, where they have the dust lanes through them that are dark, absorbing, light absorbing and light blocking dust. Well, this is the same sort of thing. Dark nebulae is dark gas and dust that blocks the light from coming through it, absorbs it, blocks it. And so this is, all these veins through here are dark nebulosity. So the neat thing about the Trifid is that it's all three. Usually you'll find nebulas with, one or two kinds, but not usually all three. Ooh, here comes that wind again. But this one has all three, which is kind of neat. pretty galaxies there. I mean, a couple of pretty nebulae there. Let's go do another star cluster. Haven't done one of those in a minute. Let's do M22. Oh, okay. Saying it's a planetary nebula. Whatever. Okay, we're good to go. Let's head over there. Yeah, nice little cluster, and again we get to shorten our... We get to significantly shorten our exposure time because it's stars. M22 is a nice cluster. Nice globular cluster. It's an elliptical globular cluster in Sagittarius near the galactic bulge region. It's one of the brightest globulars visible in the night sky. Was one of the first globulars to be discovered in 1665 by Abraham Ihle. It was included in Charles Messier's catalog of comet-like objects in 1764. It was one of the first globular clusters to be carefully studied, first by Harlow Shapley in 1930. He placed it within roughly 70,000 stars and found it had a dense core. Then in 1959 they continued the research. And some more in the 70s. It's one of the nearer globular clusters to Earth, at about 10,600 light years away. Its diameter is probably about 100 or so light years. So about a little over 10,000 light years away and about 100 light years across. Very intense little cluster there. And once again, the wind has picked up. Yeah, I'm going to do a couple of minutes more on this, and then I think I'm going to call it a night. This wind has just been annoying all night. It doesn't seem like it's going to go away completely. So I think I'm just going to call it a night after this one. Yep, our friend the wind is just going to keep on going, so I'm going to call it a night. Thank you everybody for watching. I hope you got to see something that you enjoyed tonight. Maybe you learned a little something. I will see you next time where the weather, hopefully, and my schedule allow. A lot of this really cool summertime stuff is coming up now, and so there's a lot of pretty stuff to see. So hopefully in the next couple of months we'll get some more time out here. But in the meantime, thank you everybody for watching, and I will see you next time.